I had originally asked all of the panelists to provide me a bio, and and of course Andreas, as he's allowed, the golden rule, he with the gold rules, he changed the rules on me and said, no, now everybody will do their own. So I'm going to let everybody talk, and I will provide some interesting color commentary on those folks that I know personally. So let's start with Cameron, and introduce yourself and a little bit about yourself.
Sure. My name is Cameron Freeberg. I work for Austin Energy, and I've seen many Austin Energy people here. So just to recap, we're a municipally owned utility in Austin, Texas, and I work in a group there as a utility strategist called Electric Vehicles and Emerging Technologies. And the main thing we focus on is infrastructure deployment for electric vehicles. We started doing that about 9 years ago. It started off as a Department of Energy grant and has grown into managing a network of charging stations, developing programs for EV drivers, looking at how we can integrate these EVs into utility programs, manage load. Worked very closely with a lot of people I've seen in this room already, Pecan Street included. So I'll wait for to get to the questions.
All right, and the one thing about Cameron that I know, I hadn't met him till today, but you did work for CPS before, and then you left San Antonio and came to the better city.
Yeah, I did work for CPS Energy, and I'm the only person I know that has worked for every EV program in a municipally owned major public power utility, all two of them. So.
Hello, my name is Steve Tarnowski, work for General Motors. I'm a director of electric vehicle charging and infrastructure, been in that role for about 6 months. I started out, actually where Bill did, in aerospace at Hughes Aircraft Company over 35 years ago. I've been at General Motors for more than 25 years, all in the advanced propulsion electric vehicles propulsion space. I started out on EV1. Actually, one of my first jobs was as a release engineer for inductive charging of the EV1. And so now I've got a little bit different role, not so much product development, but more strategic infrastructure, trying to make the charging experience for our battery electric vehicle customers perfect.
And you keep that one on that side. And the one thing I'll tell you about Steve is that he is an actual rocket scientist. The guy's actually sent something to Venus, of all places. So it's, from Venus, electric vehicles should be a hell of a lot easier than solving that problem. Why haven't we solved it yet?
We need more infrastructure.
All right.
Hi, I'm David Forfey. I'll be talking, wearing my SEPA and Gridwise Architecture Council hat on this panel. Full disclosure, I'm also a proud Austin Energy retiree.
Hi, I'm Taylor Prestwood, founder and CEO at Z-Bikes. We're an Austin-based startup making two-wheeled electric vehicles. We make electric motorcycles, electric mopeds, and electric bicycles. And we are looking to deploy one of the first, if not the first in the world, fully integrated intelligent transportation network.
And a little piece of trivia about Taylor is he says he's a martial artist. I think he's a mixed martial artist, and he must be pretty good because look at how straight that nose is. You must be great. I don't want to mess with you.
It's been broke before. Don't worry.
Okay. So anyhow, I want this to be a little bit more freewheeling. We actually had a prep meeting. We actually spent a couple hours going through this, and the group was wonderfully interactive, and I want to try to encourage that. So I'm gonna let you guys ask questions to one another. I'm gonna try to bring some people in from the audience who've expressed interest in this electric mobility or vehicle electrification. There are a lot of different things you can call this. But the first thing I want to do is I want to get each of you to kind of give a little perspective, what I'm going to call the multimodal nature of electric mobility. The same way we have multi-mode, from ship to train to truck to delivery truck. We have an opportunity for wait, before I start this, I'm sorry, I want my one slide. I apologize. I want to put this in context. Yeah, see, Andres, you screwed me up so badly by not letting me do things my way. You're such a tough taskmaster. No. Anyhow, I don't know if anybody's, I'm sure some of you have seen this. I love using this slide because it just puts things in perspective of, this whole issue of electrification. We can talk about it as, green energy, good for the environment, blah, 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 et cetera, et cetera. But it all comes down to money. And this is really a battle between hydrocarbons and electrons when it comes down to it. And if you look down at the bottom, follow that little petroleum line in terms of generation over to transportation, and those things are quads. And you can see the whole U.S. energy industry, well, the electric generation industry up on top, which is that yellow-brownish box, is about 37 quads today. You can see that that hydrocarbon-based propulsion, transportation, is about 25 quads. And you can see that little tiny thing that is that like hairline, almost like a mistake on the screen there. That is electric propulsion. So the opportunity here, the real battle is going to be between, hydrocarbons and electrons. And hydrocarbons, they want to keep those. They want to keep all those quads down there. And of course, the electric industry wants to take and move those up into that brown box. And that's kind of the, when I think about it, that's what it all comes down to. So again, coming back to to my first question, which was this issue about multimodal nature, because we have a number of people who play in that space, both from an infrastructure space, kind of the medium to long haul transportation space, the short haul, last mile, last 1,000-meter space, and then how you integrate all of this. I want to give you each a couple minutes just to kind of talk about where you fit in that respective chain.
Sure, and I'll start. So when it comes to multimodal transportation here in the U.S., it's virtually non-existent. Right? You have your car, you can take an Uber, which is a car. Maybe you have a friend with a truck. You can get on a bus, but you have to get to the bus stop, which means maybe you take an Uber because we don't like to walk. So when you start or you can ride a bike, right? Now there's electric bikes. There's some new options. There's dockless systems. So the things are starting to open up, but the foundation of creating a truly multimodal transportation system where larger portions of modes of transportation can integrate is a personal electric vehicle. Whether you prefer a scooter, an electric bicycle, an electric moped, or whatever the case may be, getting away from those hydrocarbons in that transportation box, the best option that's commercially available right now is a two-wheeled EV, and one that can be used for a utilitarian basis for everyone's daily needs, which means you need to be able to carry your groceries. You need to be able to maybe throw an extra passenger on there. And this is what the market is missing in really building out the foundation for the future of transportation. So what we're looking to do is really help lay that major foundation that can be built upon over time in a lot larger ways.
Excellent. I'm gonna go kind of in order. I'm gonna ask Steve to talk next, since you've just four-wheeled vehicles. I'm gonna let Steve defend those.
Yeah, I don't think in this case it's not really a defense. There's a need for that kind of transportation. At General Motors, we're a full-line manufacturer of automobiles, vehicles, trucks, cars. I think we are playing in your space a little bit too. But we've announced, maybe you've heard, our vision is for zero crashes, zero emissions, and zero congestion. And so the electric vehicles are part mostly of the zero emissions piece. So that's our vision. And as I think, was it Helen that was here earlier, talked about, this is a marathon, not a sprint. I used that, I had a chart at a presentation I did last week, said the same thing. So Internal combustion engines are going to be around for a long time. They're not going to disappear overnight. But that is where we're headed, and we're committed to that. And we've got a lot of exciting, battery electric vehicles coming out in the future. We have the Bolt today, which kind of cracked the code of affordable, both an affordable electric vehicle, 230 miles of range, so it's a great vehicle for many people. But my wife won't actually want. She's coming out of a Cadillac ELR, which is an extended range electric vehicle, kind of like a plug-in hybrid. She loves that vehicle, but she has to still make some long-distance trips. And that's where today, even with a battery electric vehicle, if it's your only vehicle, or even in a household that shares vehicles, it's difficult sometimes, and that's where the infrastructure piece comes in. That's where the opportunity is. I think there's other kinds of electrified vehicles, like fuel cell electrified vehicles, that might have a role in more of the heavy-duty, trucking delivery applications. We play in that space as well. But battery electric vehicles are going to be a big part of our future.
Great. Well, so that's a great segue into the infrastructure side of the equation, Cameron.
Sure, yeah. I think the question was, what's our role in this? And we'll give you the electrons to drive that. That's basically it. But we are looking not just, since we are the city of Austin, we're not just looking at turning things to electric transportation, but also how do we reduce congestion in our city. So these kind of smaller, easier solutions like that, don't take up the footprint of a car are very attractive to us. So we're looking at for the infrastructure, not just for the individual vehicle, but how do we get some of these smaller applications to places like maybe even low-income communities, maybe to multifamily properties where they could have like a collection of these smaller electric vehicles. And then on the complete opposite side of that, our mass transit authority in Austin just recently announced that they're looking at all electric as their future for buses. And so that's not a negligible amount of power that's going to these sites. So how do we facilitate these mass transit authorities going to electric buses? I think that's only going to start a wave of things like medium and duty heavy fleets going electric. And so how do we create kind of a template for not just buses, but medium duty fleets, heavy duty fleets, industrial applications, and providing the infrastructure for those areas, not just necessarily like a public charging network for individual cars.
Yeah. And then why don't we try to tie it all together, Dave?
So I'll talk about this from the way the Gridwise Architecture Council talks about this. So electric vehicles and electrification of transportation is going to change the paradigm and solve problems that are starting to exist every day now on the grid. If you think about the California duck curve, right? Someone in a control center every day is having to adjust and figure out what to do as the solar comes up and how to go through and make sure that it's balanced. It's a really good use of transactive energy, and George used that last night during his presentation from Siemens. Transactive energy got coined by the Gridwise Architecture Council in 2006 up at the Watson Energy Center on the first conference about it. And if you go through and say, what are the incentives for having an electrified transportation infrastructure where thankfully most of our vehicles aren't 100% used, they're sitting out in the parking lots right now. There's a lot of things you can do that you can incent that enable those type of transactions to extract the value out of the batteries and the capabilities of an electrified transportation system. Whether or not it's a scooter, whether or not it's a train, to be able to go through and take up that extra generation when it exists, and you've got the big over generation during the day in California, or more appropriately to me and my job at ERCOT, the wind blows at night, right? If you're going to have a fossil plant, it has to stay warm overnight too. If you want to lose a lot of money as a fossil plant owner, have to run it overnight when the spot prices are -20. It's not a really good economic model. If you can use the capabilities of an electrified transportation infrastructure and have the right economic incentives to provide the reliability incentives, as you start to move this direction, you get easier ways for the system to balance. If the capabilities that exist in the vehicles and the batteries can handle both the ability to be both a load and a source quickly, then you get to the point to where you have real capabilities that solve real problems from a safety, a reliability, and an economic as you move forward in the future of the grid.
David,
and as I said, I'm going to let I'm going to let them interact and have it out among themselves. Steve's ready to go at you,
well,
Dave.
actually, I want to build off of what you said, Dave, because if you think, like in the case of the Bolt, the Chevrolet Bolt, it's round numbers 150 kilowatts of propulsion, right, for several seconds, during like a wide open throttle. I mean, it's a lot of power, and batteries are really designed for the life of the vehicle. An application like energy storage for grid buffering and as a mobile distributed energy resource, it's actually pretty benign. And I know a lot of the vehicle manufacturers have expressed public concern about that, but I as an engineer, I know this is a solvable problem. You can track the energy in and out of the vehicle and make sure. I think it would be our duty to make sure that our vehicle customers, are compensated for the use of the energy. It's an engineering effort, but it's not invention. It's technology that we know how to do.
Sure.
So then the question becomes one of, okay, so you now go through and say, if you own an electric vehicle or you have electric scooters or whatever, is there incentives from the distribution utility that says, if you can park your car here and plug into phase B, it pays better, or your parking's free, as opposed to if you want to park closer to your building and I have excess capacity there, well, you actually have to pay for your parking. So understand, as you start talking about how the business models change, that's where you suddenly start to bring in economics tied to reliability, to the real problems that a distribution utility has to do to be able to balance that distribution grid across 3 phases every hour of the day.
And that leads right into Cameron, our distribution.
And that's not just, full disclosure, I know nothing about distribution systems.
So much for that.
But that's not just around electric vehicles, but the way that utilities are looking at energy storage as well. I mean, that translates directly to electric vehicles. I mean, so I don't know how much went over the Shines project of what we're doing with energy storage and pairing it with our distributed energy resource optimizer. But we're looking at multiple value streams of how you leverage that storage for value on the distribution grid, or to the customer, or to whoever it is. And so, I mean, the way we look at it is, okay, we're not necessarily worried. People might go out and get batteries within their garages, install them, and they're stationary. But we have around 8,000 electric vehicles in Austin right now. And as that number continues to grow, I mean, at a very rapid rate, we have to look at it like, okay, well, this is the same use case as these residential storage systems, but just on wheels. So if you start getting V2G capabilities, or can actually solve problems on the distribution grid with those electric vehicles, I mean, there's a huge amount of assets out there that are, can be utilized by the utility.
Okay, so let's take that. Let's go. So I'm going to divide you guys up for a moment. So Taylor and Steve, your OEMs, you ultimately sell to the customer. They are providing that battery. Then you have, the distribution grid into which that connects. Presumably, it wants to, you want to have a flow of energy. You want to, there's a demand response component to this. You don't want to be drawing at 220 volts, 30 or 50 amps, and have, the grid collapse. And then at the top side, you also have, I'm going to think of you as a trading arm. I'm going to ask you to put on your ERCOT hat, not the Grid Alliance hat. This is great. It's like 2 for 1 I got here. And put on your ERCOT hat. How do all of you, coordinate for the benefit? How does this all work together for the benefit of the owner of that vehicle? Because I know that, frankly, distribution utilities tend to want to think, I want to get that battery use for free. And it isn't going to be free. How is it going to be? How are you going to monetize it? How are you going to utilize it? How are you going to compensate your customer? And how are they going to both extract and offer energy to the grid?
I mean, from a utility perspective, we're basically looking, how do we interact with ERCOT for those charges that come to us? So
But you just said that model will not scale down, that it's a different model, taking it down to the distribution level.
Yeah, and so I mean, right now, like the stuff we do with thermostats around the curtailment and 4CP with ERCOT, we're looking into the same things with electric vehicles. It's the same exact formula. The controls are in place to be able to speak to residential charging. You could potentially do it on the commercial side, but that's not necessarily a service we want to cut off to people that might be in need right now. But if we're doing curtailment to residential charging, which is not temperature-based load, so people probably don't care as much when you cut their charging off versus when you cut their thermostat off when it's 105 degrees. So we as a utility get value out of doing that curtailment, and so we pass that down through incentives to the customer for enrolling in those programs. On the flip side, we also are looking at it as from time of use rates. So we have a time of use pilot for EVs specifically limited to 100 customers. Basically stay off or don't charge between 3 and 7 on a separate meter. Achieves the same goal. Hopefully, keeps us from using that energy during peak periods. But we don't know. We don't know which model utilities will end up going with.
So today, unfortunately, we have both the perceived and a real charging infrastructure problem, and until that's resolved, our customers want ever bigger batteries, more range, more range. What does that mean? More cost. So as we start to solve the infrastructure problems, I don't have data to support this, but my hypothesis is the pressure to ever larger range and bigger batteries will ease, and this thing will settle out at some value. We have a lot of data. We talk about the value of the data on the analytics of how our Chevrolet Bolt customers use their vehicles today via OnStar. So every time the customer agrees to the OnStar agreement, when they get their vehicle, they are signing up to allow us to use their data, to aggregate that data. We follow all the privacy laws, and we're very, very careful about how we use it. We make sure we strip out all the personal information. It's all aggregated. But we know how the customers use those vehicles. And like fourth quarter last year, the typical Bolt, I'd say the mean customer probably used it's a 60 kilowatt hour battery. They probably averaged about 6 kilowatt hours, a day. So about a tenth of the pack. So they don't know it really. They don't think about it, but they really don't need these giant packs. Now, there are times when they do it, those times when they take long trips. But most of the time, especially during the week, right, that there's a lot of energy that's not being used. It's just sitting there. And it's expensive, right? They're paying for that, and right now they're only using it for propulsion. And I think there's obviously more uses more good we can do with that energy.
On the so let's talk about the last mile solution. The battery scale isn't completely different. What do you see a similar issue of the underutilization of the battery?
Sure. So for us, because we're on low power systems, it doesn't make sense to say use an electric bike to feed back to the grid like it would with a larger battery pack in a car. But with our smart hubs, those will be, all of our batteries are removable. So whether it's a moped or a bicycle, you can take that battery out. You can swap it from full to empty. You could take it into work to charge. You could do whatever you want. It's just got a small converter that plugs in the wall, and that's how our systems charge. So we completely bypass the need for infrastructure for our end users. But the infrastructures that's required for the first mile, last mile to be put in place are going to be hub-like infrastructure. So we're going to be putting together smart hubs, which will be placed strategically throughout the city to work with the transportation systems in the high points in the city. Now those hubs could be plugged into the grid and feedback, because they'll have a substantial number of batteries that are going to be fully charged at all times, and it'd be quite easy to just feed those back in, say, during peak times or whenever it would need to be. You just have to coordinate with Austin Energy. So for our infrastructure systems, those would be quite valuable in the battery storage.
So Dave, why don't you tell us why that won't work?
Well, and instead of going in and doing the supposition, generally the way to think about an ISO is we need a certain amount of scale. At a prior conference, I saw a former FERC chairman talk about a day in the life of the grid and how the economics go. At some point, you have to get the scale. things within batteries within Austin Energy are different given the way the ERCOT network is configured. There are different rules that apply to municipal utility versus people in the competitive zone. But the way to think about how you have to go through and say, what's the aggregation? The big value you get for people who own mobile devices and mobile transportation, think about the post office, think about the school bus yard, if it's that where you've got a big enough capacity to where you have enough information and can make assumptions about those batteries that they can do the functions you need at the time you need them to do it. Because having a full battery is really cool, except when you need it to take in more charge because you have excess generation, right? Having an empty battery that says, well, okay, we're short on generation, don't charge, doesn't help. So the more you can go through and start to use the laws of large numbers and go through and say, okay, I have people parked in a parking lot in San Francisco with all the EVs and they're going to be at their 11-hour-a-day job. I have a pretty good idea about how to balance out what's going on in that area. But a single car behind, or 3 cars behind one transformer is a much more difficult problem to solve because there's fixed amount of capacity. I've got 3 people. It's a much different value proposition. So that's the reason why at the total grid and in the aggregate, things like parking lots and things where things are aggregated from a battery perspective are really helpful. And when you start talking about it behind an individual transformer and trying not to exceed the limits on that transformer, when you have 3 people who want to charge at the same time, that's where you start to talk about what's the peer-to-peer rationale for saying, you get premium, you're going to pay a premium for that energy charge because I don't really need to charge my car, I won't pay enough to go through and exceed the limits of the transformers. So think about the problem that way. There's the law of big numbers that helps, and then there's the law of small numbers, which is really hard to predict and has lots of variation.
All right. Well, yeah, questions? Yeah, please use the microphone. Yes. Please state your name and your affiliation, and then ask your question, please.
CMG. Thank you, Bill, for telling me the rules. So here's a use case. And if you haven't read the book, it's in chapter 4 and it's in chapter 7. So here's a use case. Austin Energy produces, it's a vertically integrated utility, and it produces, megawatt hours. It buys some stuff, renewable. But let's just, for simplicity's sake, let's say that they produce 3,000 megawatt hours, just to keep the numbers simple. So then Steve is going to make a new car, which is the Cadillac Super Duper 100 kilowatt hour car.
Yeah.
So it's a new Cadillac. It has a 100 kilowatt hour battery. That means that if Steve were to sell 30,000 of those cars in Austin Energy could actually, with a program, store 1 hour of production in those 30,000 cars. Now that would be a game changer. Now there are 22 million registered cars in Texas. 28 million people live in Texas. There are roughly 1 million registered cars in Austin. Roughly, in greater Austin is 2 million people. So the fact that 100,000 new Cadillac Super Duper 100 kilowatt hour battery cars could be sold in Austin in the next 5 years is very likely. And the question is, for Cameron and Forfia and everybody else, using the laws of big numbers and assuming that you don't have to charge or discharge the entire battery every time, but only a few trickles times 30,000 cars times 100,000 cars, what would that do to the grid? What would that do to the monetization of the grid? What would happen to the system if 10 million cars were all electric and connected to the grid? What would happen? Who wants to go at it?
All right, Dave picked up the mic first.
So I'll start out with the easy use case that Andre started out with. The challenge you're going to get into that says, okay, I now have enough to handle 1 hour of load. Well, where that person's going to plug it in was determined when they purchased their house. It wasn't determined when they decided to go out and buy their electric vehicle. So I'd like to say hopefully it would be random, but what I can tell you is after working and riding around in bucket trucks long enough, I guarantee you everyone who went through and bought the electric vehicles would all be on A phase, right? And when they go plug it all in, okay, great, I have 2 phases that underserved, and I've got one that's overloaded, because you don't know. And in all honesty, if you get to much higher penetrations where you can start to say that the law of large numbers starts to peanut butter it across, you have something that as a distribution engineer, people can engineer around. But if you're responding to negative and random events based upon the speed of the consumer and the choice of the consumer, it is a different problem to solve. So your initial use case, I think, will produce surprising results that are more problematic than we could have forecast. A larger penetration, I think, will do better.
All right. So
I just wanted to add, because you mentioned home charging, which most of the charging from our battery electric vehicles are at level 2. It's 6, 7, 10, 11 kilowatts kind of thing, and also workplace, which is an area that we're just beginning to really focus on at General Motors. There's a big opportunity there. There's studies, DOE programs that show companies that have workplace charging have a much higher percentage of folks that actually buy battery electric vehicles. This is all good for all of us, right? You sell more electricity, we sell more electric vehicles. So it's roughly
Ron,
over 90%.
That.
Yeah, over 90% of the charging takes place at home or at work. So those are what we want to do, and those are the impact on the grid isn't as bad. It's the en route that the DC fast charging, the 10%, that's more of a challenge.
Great. And I want to, if I can jump in real.
Can he answer?
Okay.
It's on their rules. So
Yeah.
yeah, I think one of the areas that scenario you're painting it's scary. I mean, if we talk about 500,000 cars coming in, plugging in it, we're looking roughly like 6.6 kilowatts right now. But when you start hearing numbers of like 350, it's DC fast charging, but these are some scary numbers. So from the residential side, that's where we know that majority of charging is happening. Is how do we start making that connection with that charge, with either the vehicle at home or that charger at home? And so there's very easy ways to to aggregate it, maybe even set thresholds for how much you want this aggregate group of cars to be pulling off the grid at one time. So a voluntary program, and so you can set those caps. What we're really looking at is we're looking at banks of DC fast chargers. I mean, right now we're looking at deployment of 50 kilowatt fast chargers in clusters of like 2 to 4. When we start seeing these 150 to 350 kW chargers come in those clusters, I think that's where it's going to get a little bit different.
Those are only for Porsches, but there are plenty of those in Westlake. Yep. So, yeah. But you know what I want to do? I want to jump in because we've moved on to this infrastructure piece, and I promised, and then we'll open up for questions here in a moment. But I wanted to kind of pick on 2 of our municipal parties here. I'm looking at both Helen and Ying, and I want to ask their perspective relative to this public and en-route charging challenge, this problem that you have. So, for example, you just said you'd want to limit DC fast charging. Well, guess what? If I'm in the business of retailing DC fast charge energy, I don't want you turning me off at 4 o'clock. Okay? So how do municipalities kind of play in this? How does a municipal government work in this? Either both when you when you also have a muni or when you have an IOU. How does that? How are you going to either support or constrain that? And Helen's right up, ready to go.
Well, first of all,
there it is.
first of all, I think everything's a collaborative, so I don't think that it should be an all or nothing approach, just like any negotiation. So I think that there be, the question is, should there be a cap? Well, maybe there should be a cap for a certain period of time. I also think that the EV charging stations, just going as a municipal, I think the commercial and retailer, and with regards to infrastructure, there's different types of infrastructure. One's the charging stations, which you need, and is a retailer willing to put it in, and me as a public agency, should I be requiring it? Okay, and then also who pays for that?
So what's your position in Brownsville?
I think that it should be made required to a certain point, but I think I should also look at the economics. So I'm not all for one or the other.
Okay.
I'm neutral.
I'm going to ask Ying to, since he opened the door on this when he spoke earlier, I'm going to look at this. He just moves right on to the, just, help yourself.
Don't size myself up as a big guy.
I'd be careful.
Oh no, he scares me just for that.
He scares me too.
I'm a nice guy.
I know. Oh, I believe you.
That's
It's
what
just
they all say.
The missing teeth in the front, maybe. So I think for us, anyways, outside of AE, right, I'd be looking at the equity equation, right? So we're talking a lot of things right now that most of our population cannot afford, right? So how do I leverage, right? What is the city policy around distribution of these hubs, right, to bring equality back into the city? So help the more impoverished areas, bring in some revenue maybe, or ask that, you all have programs that go beyond just the vehicle, right? You guys had a rideshare Cadillac, whatever program there at GM that I thought was brilliant, right? You're out there trying to encourage community, right, to look at alternative mobility options, right? So I would pull that into the policy discussion, right? As we place these charging stations strategically, I would definitely want to push inequality, pushing it out into the community kind of.
Yeah, actually, and I agree with you. I'm not going to talk about our competitors, but I think there's an opportunity to put DC fast charging in communities that are, generally underrepresented. They don't have a lot of the urban areas, the multi-dwelling units in urban areas, they don't have access to home charging. So they would either have to rely on work or DC fast charging, which is it's expensive. They're going to pay a premium for it, but at least it would be an opportunity, if they're out and about doing shopping, to charge their vehicle for 30 minutes, or maybe even bring in more economic development to the area, because if the urban area is near a big interstate and there's people driving by and they have access to come into that DC fast charger and provide income to the area, that I think there's a lot of opportunity there.
Yeah. So and we also have like rideshare programs or Cap Metro and other ways that we encourage, right, alternative forms of transportation or modes, right, ride sharing and stuff. And also, again, we can put access to these expensive assets, right, into the hands of folks that cannot afford them, right? I think that's a big push to push the energy out. And those are the folks most likely looking for the alternative, especially the last mile, right? I can probably afford a $200 scooter, right? But
A little more than that, but
Well, and that's part of what we've learned during our journey so far is that there's a massive demand for our products to serve the low-income communities for multiple reasons. One, they're reliable. Two, they're cheap, much cheaper than a car. And three, they're very easy to maintain and they're very portable. So this opens up the lanes to get more productivity out of the communities, means more income, which means what are they going to do? They're probably going to go get a car at some point, right?
They'll move up, yeah. So I have only a few minutes, and I'm going to warn you, if you guys, I'm going to pick on the Purnell's Co-op folks. If nobody else asks a question, I'm going to ask one of them. So if you want to spare them, somebody ask a question. Otherwise, I'm going to ask them a question. No questions? Okay, so I want to ask PEC. Amy, we talked last night. I'm going to put you on the spot relative to this. You're a shareholder-owned cooperative, and you stated that it is not your position at this point to invest in charging infrastructure today. Why?
Because we're a member. Over there.
Yeah, please state your name and we have a seat for you.
So hi y'all, I'm Amy Akers, Board Director for Purnell's Electric. And so we are a member-owned electric co-op, which means that we owe everything to our members and our employees. We have to account for every single one of them. And so for us to make any expenditure, we have to weigh all of the costs and ask our members if that's what they want. And so right now it's something that's being looked at, but it's not something that we're ready to implement today.
Okay, So, and do you think that's generally kind of the view of the 3,200 plus co-ops, and isn't that about what it is?
Yes. So
Yeah.
900 co-ops.
Oh, only 900 co-ops. Sorry.
we have a very diverse membership. We have members who are very rural and members who are very urban. And so it's very different from a muni such as Austin, where you have more electric vehicles. We have electric vehicles on our system as far as members. We have members that own them, but most of our usage would be if we had the charging stations would be pass through. People traveling from point A to point B.
Right. So therefore, it doesn't benefit the members. Ergo, let somebody else make that investment who can better monetize it.
At this time.
Okay, thank you. We have a couple more minutes. Maybe I'll allow each member, including Ying, who's now joined us, to give a final comment. I'm going to start with you, in fact. We'll go this way.
30 seconds. 30 seconds.
So I'd like to kind of leave you guys with a thing, right? I think one of the things that we're learning and we're discovering in the city is policies around some of these emerging technologies, especially things that surprise us with their popularity and capability, like scooters, right? I think you can see that almost every municipality is struggling, right, with what to do with these scooters, right? They're inherently dangerous. You know, people are not taking caution, right? They're not permitted or whatever, and it just goes all over the place. But you cannot argue that they're super convenient, they're awesome, right? And they solve a problem. So same with electric bikes. We don't have that bad in Austin, but you go to Dallas downtown, it's a disaster, right? I mean, let's be honest. So I think the policies around some of these emerging things are important, and I like to kind of engage in how do we kind of see the future coming as you guys are building your hubs and building your programs. What should we do at the city to kind of anticipate some of this that are coming?
That's the next panel.
Well, and kind of on that point, because the dockless systems that's what showed up first, and that's what we kind of accepted as is, even though it's really one of the worst models that you could create.
Do you have an opinion on that?
You know, well, I only watched it in China for 3 years before it ever showed up here, so I'm very familiar with how it operates, both on the front end consumer side and then the back end on how it works. So really the medium is going to be more of like a subscription based, more of quasi-lease, monthly rental type services where you have a connected fleet which is constantly being recycled and reused throughout the consumer base. Can also be used on B2B solutions and larger projects that way. And that pretty much null and voids any need for policy, because it's no different than your phone or a car or anything else that you pay a monthly subscription fee for. So then therefore that enables massive adoption at a fast rate where you don't have all the worries that the dockless systems and the problems that the dockless systems create. It's a way to kind of self-organize and manage that operation through the liability on the end consumer. You know, when you have something and you use it and you take it home, you take better care of it. If you view it as a disposable toy, that's how you treat it. And that's ultimately what these dockless systems are, is a widespread disposable toy system.
Well, I'm glad. Do you have an opinion on that?
We spent a lot of time on this panel talking about the economics and how this goes through and ensures the great operation of the distribution network and the transmission network, and how the economic incentives drive that reliability. But the key point I want everyone to take away as we have this discussion, economics and all the things we do to incent the right behavior ensure reliability right up until the point they don't. At which point there's other rules that go through. So as we start talking about what are all the things that you can do and what you can do with economic incentives to go through and ensure the right things happen, ultimately, what we want to ensure doesn't happen is that everyone goes from having electricity to being dark really quickly. And ultimately, that's why rules are in place. That's the reason why we have the resiliency requirements. And that's the reason why economics work to a point. But at some point, even if you did invest in that charging station, if the thing comes between you making some money with that charging station or everyone in that feeder not having power, we know
the charging station loses.
The charging station's going to lose the same way if anyone does any bad behavior on the distribution network. There's a reason why all those really cool things are on the line to ensure they go from open to closed really quick. or the other way to ensure that no one gets hurt, that people who climb the poles are safe, and that ultimately everyone has access to power.
Steve?
Okay, well, I'll start with what we saw last night, right? The future is electrified. This is really coming. It's happening. It's now. Whether it's personally owned vehicles or shared vehicles, the ones you drive or the autonomous ones, they're all, in the future, they're all going to be electrified. We need electricity. These vehicles can actually, where is all that electricity generation going to come from? That little thread that Bill showed at the beginning, right? A lot of it's going to come from renewable, solar, wind. It's transient in nature. It's got to be stored. So these same vehicles that I'm talking about can also be part of the solution. So we need to work together. You guys got to buy lots of electric vehicles, sell lots of electricity. It's a win-win, and we're in this together.
All right.
I'll start. So I mentioned how scary DC fast charging is. We're actually installing an entire network of it ourselves. So we just need this to be close, but we're still putting it out there, and we want it in our territory. And I know we talk about how do we manage that load and all that stuff, but I think one of our roles is we're really we want to facilitate the adoption of electric transportation across every sector. That's really what we're looking at the utility, and that's everything from getting building codes from the equity issue. We've installed EV charging at low-income neighborhoods. Probably put the cart ahead of the horse, but we know those prices for used vehicles are going down. We're looking at changing building codes. So if someone wants to come in and install infrastructure later, it costs them hundreds of dollars versus tens of thousands of dollars. So just simple things like that to get policies in place to facilitate in the future. I think that's really what we're looking at, is just continuing to get that growth of EVs in Austin. So.
Fantastic. Well, I want to thank all of you. Please, a little applause. I made it very difficult on them, and I want to thank them all for attending the panel.
Nice job on the panel. Thank you.